In the last videos, we started the rules for counting atoms. We started part 1 and we talked about subscripts. Today, we're going to start part 2 of 3, which is concerning coefficients. So quick refresher, this is H2O. This 2, which is below the hydrogen here, is known as the subscript, and it lets us know that we have 2 atoms of hydrogen. Now this oxygen does not have any number behind it, so we need to know that there is an invisible 1. And if it helps us, we can go ahead and write that there. Okay, here we have a grocery cart with 3 peppers and a strawberry in it. So if I were to write that down, I would say that we have 3 peppers and 1 strawberry. Now never mind the fact that they are ridiculously oversized. Now, what would happen if I were to, say, clone this, and suddenly I had 3 of these? How would I figure out how many of these grocery carts I had and how many of the groceries inside of them do I have? Okay? Well, I would say how many total grocery carts? I would say I have 3 grocery carts. That's pretty easy. We just count them. And because I have 3 grocery carts, then I'm going to multiply my 3 peppers times the 3 carts and give me a total of 9 peppers. And I'm going to multiply my 1 strawberry times 3 to give me 3 strawberries. And if I wanted to, I could count this and I could confirm it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 peppers, just like I figured out when I multiplied. And I have 1, 2, 3 oversized strawberries. Now, if we look at this situation, we have a molecule of nitrogen with 3 hydrogens bonded to it. Okay, so right now I have 1 molecule. So that's pretty easy to write. I would write this as a chemical formula, NH3. And I would know that there's an invisible 1 down here in that nitrogen. Now, if I were to do the same thing, and I were to clone that, I would say how many of these molecules do I have now? Well, I have 1, 2, 3. So we would say I have 3 molecules. Okay? Now, I would write that by putting a 3 in front. We call that a coefficient. Now, just like back here, we multiplied 3 peppers times 3 because we had 3 grocery carts. We're going to do the same thing here. So how many nitrogen do I have overall? Well, I have 1 nitrogen in every molecule, and I have 3 molecules. So 1 times 3, I have 3 nitrogen atoms. How many hydrogen do I have? Just like the peppers over here, I have 3 in each molecule, and I have 3 molecules. If I wanted to, again, I could count 1, 2, 3, 4, 5, 6, 7, 8, 9. That's exactly what I came up with here. So, when we're counting atoms, for each atom we ask these questions. Number 1, is there a subscript? Okay. If there is no subscript, we know it's an invisible 1. 2, is there a coefficient? If there is, then we multiply them together. And we'll have one more rule coming in the next video, and that's it. Let's practice this. I have 3 C6H12O6. That's 3 molecules of glucose. So really, it would look like this. I have 3 molecules of glucose. So how many of each atom do I have? All right, carbon. I have a subscript. Is there a subscript? Yes. Is there a coefficient? Yes, it's 3. So we have a total of 18. Hydrogen. I have 12 as my subscript, and I have a coefficient of 3, so it's 36. And oxygen, I have a subscript of 6, and a coefficient of 3 equals 18. I want to see this step every single time. It is never okay to do that step in your head. Now, what if there was no subscript out here? How many molecules do I have? If I just look at it, it's pretty easy. I'd say 1. So just like before, when there was no subscript, if there is no number in the front and I ask you how many molecules there are, then you're going to tell me that there's 1. Okay, let's look at another example. Here we have 2 baskets. Each one has 2 carrots and a pepper in it. Then we have a separate basket that has 3 peppers in it and 1 strawberry. So if I were to ask you how many baskets are there, it'd be pretty easy. You say there's 3 baskets in total. And if I asked you how many groceries are there in total, well, we would say, all right, in here we have 1 pepper in this basket, and there is 2 baskets of it, so that's 2 peppers. There's 2 carrots in 2 baskets, so that's 4 carrots. And then we would add that together to over here we have 3 peppers. We have 1 basket and 3 peppers for a total of 3 peppers. And we have 1 basket with 1 strawberry. Give us 1 strawberry. We would add these together, and in total we'd say there are 5 peppers, 4 carrots, and 1 strawberry, right? So this isn't any kind of science. We could count this if we wanted to. 1, 2, 3, 4. There's 4 carrots, 1, 2, 3, 4, 5, 5 peppers, and 1 strawberry. All right, let's look over here. Now let's turn it into chemistry. We have 2 molecules of this NH3. And then we have 1 molecule of NO2. We're going to follow the exact same things that we did with our grocery basket example. Start from the left. We're going to ask our 3 questions, or 2 questions so far. We're going to ask our 2 questions. Is there a subscript? If there's no subscript, it's an invisible 1. So for nitrogen, it's 1 times 2. There's 2. For hydrogen, is there a subscript? There is. 3 times 2. There's 6 hydrogen. Now we move over here. Now this plus sign means that we're to a whole new basket. We didn't, because there's 2 baskets here, we didn't multiply everything in here times 2. That wouldn't make any sense. We're to a whole new basket. So there's only 1 of this molecule. So invisible subscript of 1, invisible coefficient of 1. In here, we have 1 times 1 equals 1. So that's going to give us a total of 3 nitrogen. All right, and then oxygen. There's 2 oxygen times 1 for a total of 2. So in total, if we added them all up, in nitrogen there are 3, in oxygen there are 2, in hydrogen there are 6. So right here is my answer.